Okay, we are going to take notes first, so whenever I write something down, you should be putting this in your notes. Okay, we're going to talk about the real number system. When you talk about the real number system, it's indicated by the capital R. Okay, real number system is now broken down into two subgroups. And we could say irrational or rational. Let's change those colors. We'll say irrational would be, let's make that one red. Irrational, which is indicated by an I. And then let's make our rational green. And that one we use a Q. Okay, it doesn't matter if the rational's on the left-hand side or the irrational's on the right. It doesn't matter. It's just they're broken up into two separate groups. Okay, so now we're going to look into in the section of irrational. So sometimes when we're getting a number, we have to decide, is it irrational? If it's irrational, we're done. It's an irrational number, and it's also a real number. But if it's a rational number, then it has subsets within it. So let's look at those subsets. The first subset we're going to look at, we'll start at the smallest within the center. We'll talk about a natural number. And we use an N. Okay, so a natural number are our counting numbers. So we'll say counting numbers. And our counting numbers are 1, 2, 3, and so on. The next subgroup, let's use this one, we would call whole numbers. Whole numbers we use a W. So your whole numbers are your counting numbers plus 0. So the only difference between those two is you add a 0. Okay? And then the next one would be, let's change the color up there. Let's do our integers. We already have red, don't we? And we'll have to keep on using it. Okay, integers. Okay, and that's represented by a Z. So when we talk about integers, the definition is the whole numbers and their opposites. Well, there isn't an opposite of 0, but there is an opposite of 1, which is -1. And then you have -2, -3, and so on. Okay? So we have natural numbers, whole numbers, integers, and rational numbers. Within our rational numbers, there's some other things that are put in there. So we have fractions. So if we have a fraction, it's a rational number, and it would be a real number. So let's put some examples of fractions. We know what they are, but let's just put them down there anyway. 1/2, 2 1/3. That's a mixed number, but it's also a fraction. It can go improper. And we can even say -1/2, and we can say -2 1/3. You can have a negative fraction. All it means is it's just to the left of 0. Okay. The next type of irrational number would be terminating decimals. So, terminating decimals would be something that terminates. So we need a decimal and then it terminates. So we'll say 3.2. It stops, right? There's a decimal in there. It's 3.2. -3.2. Okay, you can still have negatives. 4.25. Notice it stops. It doesn't continue. And the other type of rational number would be decimals repeating with a pattern. So there's some kind of pattern there, okay? Decimals, and I'm just going to write decimals with a pattern. So those repeating decimals that have a pattern. So the example would be, let's say, 4.17. If we look at that, that bar indicates that the 17 continually repeats. So with these, you would know what the next number is. So if I asked you what the next number is, you would say 1. Then the number after that would be 7. Then you would say 1 and then 7. So you can find that pattern. Another number could be 4.444, right? There's a pattern of 4. We can rewrite that as 4.4 with a bar over it because we know that we have 4.4. You can also have negative numbers. It can be a negative. So let's see, we could say negative 6.798798. Would you be able to look at that and tell me what the next number is? Absolutely. It would be 7. Right? And then we'd have a 9, then we'd have an 8. So those are rational numbers. So let's take a look at this. So basically, if we get a number, we have to determine where it belongs. For example, let's say the number is 0. Well, 0 is not a natural number, but it is a whole number. If it's a whole number, it's an integer. Then it's a rational number, and it's a real number. Okay? There are other numbers. So basically, if you say it's rational, it could fall within the integer, whole, and natural. Or it could just be rational and real. It all depends on what you're given. Your irrational numbers, those are things like pi. Okay? They're non-repeating decimals. Example, 4.1768. I don't see any number right there that that's repeating right now. It's not indicated. And I honestly don't know what the next number is. Do you? If you don't know what that next number can be by looking at that number, it's automatically irrational. Okay? And the other ones we can look at are non-perfect squares. Okay, so example, the square root of 30. If I put that in my calculator, I would get a number similar to that 4.178. I won't know what that next number is. Another example would be the square root of 86. Okay, so now here we're going to actually take a look at these numbers and figure out where they belong. Okay, so when you're asked to do something like that, it's a really good idea to memorize that diagram. We call it a Venn diagram. There's plenty of ways to write it, but we're going to draw one that's similar to that. We're going to say real numbers. Right? And then those real numbers are broken down to irrational and rational. Within the rational, we have natural, we have whole, and we have an integer, which is z. And then we have that rational numbers, okay? Oops. Okay. All right, so now let's take a look at 30. Well, 30 we know is a natural number. We can count that, right? Not necessarily on our fingers, but if we keep on going, we'd get up to 30. So we know that's a natural number. If it's a natural number, it's also whole, because whole numbers start with 0 and they go up. Remember your definition for an integer. Integers are positive and negative numbers, and 0, so the opposites of the whole, so it has to be. And then if it's a rational number, if it's an integer, then it's also a rational number, right? And then it has to be real. So they're all real numbers, the ones that we're looking at right now. So if we take a look at number 2, negative 11, well, that's not a natural number. It's not a whole number, but I know it's an integer. If it's an integer, it's rational. And if it's rational, it's real. They're all real numbers on this page. Now let's look at number 3. Well, that's got a fraction in it, so I can't even start at natural. I can't, it's not a whole number. And it's not an integer, so it's a rational number, and it's real. Number 4, number 21 is not a perfect square. If you put it in the calculator, you'd see it keeps on going, right? You don't know what it is, it never stops. So that one is irrational, and it's real. 0, it starts at a whole number, right? So if it's whole, it's an integer, it's rational, and it's real. Number 6, we have to solve it first. The square root of 9 is 3, and now you bring this negative sign down so we have negative 3. And then you put it in its subgroups. Well, a negative 3 is an integer, because it's negative. Then it has to be rational, and then it's real. Well, this one says 6 divided by 3. That gives me 2. So 2 is natural, whole, integer, rational, and real. And pi, we found out it was irrational, so it can't be on the other side of that table, and it means it's real. Now that we're looking at this one, it has a decimal in it, so it can't be natural, whole, or an integer. And now we have to say, is it rational or irrational? Well, it's rational because we see a pattern. So we're going to say it's Q, which is rational, and then it's a real number. Okay, I will see you tomorrow.